Hello everyone, thanks for watching my video today on arithmetic sequences. Before we begin with arithmetic sequences, let's talk about what we learned yesterday. I'd like you to pause this video, look at the four sequences you see here, and try to write an explicit formula for each one. All right, try to look at the pattern, see if it's linear, quadratic, or exponential, and use what we talked about yesterday to try your best to write an explicit formula for each one. Pause the video now and unpause it when you've tried each one. Okay, here are the answers you should have come up with for these four. Okay, if you did not come up with them, don't worry. Today we're going to learn how to do these, and my next video we'll learn how to do these. Much easier than just simply guessing. Okay? So let's talk about arithmetic sequences. An arithmetic sequence is a constant difference, which we call D, between consecutive terms. So right now, let's just look at these four sequences. Are they arithmetic? Is there a constant difference between each set of terms? Let's see the first one. Goes up by 6, goes up by 6, goes up by 6, goes up by 6. So this one is arithmetic, and the difference is 6. Now yesterday we didn't call it arithmetic, we called it linear. Linear and arithmetic are basically the same thing, but in the sequence world we call it arithmetic. Next one goes up by 6, goes up by 18. Well, we already can stop there. The answer is no. It doesn't matter what the third one does. That one is not arithmetic. Third one, add 4, add 4, add 2, add 2, add 4. So again, we're adding different numbers each time, so this would also be no. And the last one, subtract 8, subtract 8, subtract 8, subtract 8. Yes, this one is arithmetic, and our difference is -8. So here, finally, is the explicit rule for any arithmetic sequence. So going back to our warm-up here, this one and the denominator, this one, you no longer have to try to guess at what this would be or try to find a line that it will work with. This formula will work for every linear or arithmetic sequence. A sub n is the nth term, a sub 1 is the first term, n is what term you're looking for, and D is the common difference. We are going to fill in A1 and D. So the first one says, write the explicit formula for this sequence. Let's first make sure it's arithmetic. Add 15, add 15, add 15. Good. This is arithmetic, which means we can use this equation. So A sub n equals A sub 1, which is the first term, 32, plus n minus 1 times the common difference, which is 15. And that's it. That's our explicit formula. Now, it would be also beneficial if maybe we simplify a little bit. So a sub n equals 32 plus 15n minus 15. And finally, a sub n equals 15n plus 17. Okay? So these are all the same formula. This is just a simplified version of it. That's all. Now, to find a sub 12, we're simply going to put 12 in to what that would be. And let's see if we can figure this out. 15 times 12 is 180 plus 17 is 197. So the 12th term would be 197. Example 2. Given that we know that the 8th term is 50 and the common difference is 2, write an explicit rule. All right, so we know this is our explicit rule. Let's substitute in everything that we know. We know that 50 is the 8th term. I don't know the first term. I know that we're looking at the 8th term, and the common difference is 2. So 50 equals A1 plus 7 times 2. So A1 must be 36. Now take A1 and our common difference, and let's write our final answer out. So A sub n equals 36 plus n minus 1 times 2. That would be our rule. Again, be a good idea to simplify this. So 36 plus 2n minus 2, 34 plus 2n, or 2n plus 34. Example 3, two terms are given to us this time, but the common difference is not. Write an explicit rule for the nth term. Then find the value of n for which a sub n equals 70. All right, so I'm just going to start here by writing down our explicit formula that we just learned. Okay, so I'm going to put this one in, make a better bracket than that, 10 equals a sub 1 plus 4d. Everyone okay with where I'm getting 4, I hope? 5 minus 1, right? So 4d. Then I'm going to put this one in. So 110 equals a sub 1 plus 10 minus 1, so 9d. All right, now this is simply just a system of equations, okay? We've got to figure out a way to solve a system. How about we multiply this by negative 1 and add together. So we get 100, a1s cancel, equals 5d. Divide by 5, we get 20 equals d. And I can take the d value that I got and put it back into either of these two equations. So that's 80, subtract 80 over, we get negative 70 equals a1. All right, so now I can write out my nth term is negative 70 plus n minus 1 times 20. Or negative 70 plus 20n minus 20. Or 20n minus 90. So that is my nth term. Then it says, find the value of n for which a sub n equals 70. So 70 equals 20n minus 90. Add 90 over. And divide by 20. We get n is 8. So the 8th term of this sequence would be 70. All right, number 4, find the 500th term of this sequence. All right, well, let's make sure this is arithmetic. Otherwise, this is going to be a pretty hard problem to do. Add 5, add 5, add 5, add 5. It looks like it's arithmetic to me, so let's write the nth term. A sub 1 plus n minus 1 times d. d here is 5. Let's just simplify this a little bit. Negative 4 plus 5n minus 5. 5n minus 9 would be our nth term. A sub 500 is 5 times 500 minus 9. Ooh, let's see. 2500 minus 9. 2491 would be our 500th term. All right, last one here, a word problem. Tommy earned $50,000 in his first year at the job. He gets regular raises on a yearly basis. His second year, he earned $50,700. His third year, he earned $51,400. How much would he earn in his 25th year? So let's stop for a second and recognize this is arithmetic. We're adding 700 each year. So nth term would be a1 plus n minus 1 times d. All right, if you want to simplify this, which again, you don't have to, but sometimes it makes things a little bit easier. 700n plus 49,300. Now if we put 25 in there, 700 times 25 plus 49,300. I'm not going to try to do that one in my head. I'm going to go to my calculator here. 700 times 25 plus 49,300. In his 25th year, he'd be making $66,800. All right, so that is the end of our video today on arithmetic sequences. Thanks as always for tuning in, and we'll see you again next time.